Today we are going to see about physics in food. Physics is not only applied in food and its product, but we come across physics in our day-to-day lives. So today let's see about physics in food. Today we are going to see physics in two products. The first one is cotton candy and the second is marshmallow. Let's go into the physics in cotton candy. Introduction to cotton candy. As we all know, cotton candy is the most liked product for all of us, not only for children, but it is also liked by all of us. It is only because it caramelizes, the sugar caramelizes, right? When you put it into your mouth, it just goes and we'll not even have a feel that we have ate it, right? Cotton candy is originated in Europe in the 19th century, and before that even this concept was introduced in the 16th or 15th century, but still cotton candy, the term was introduced in the 19th century. Cotton candy, also known as fairy floss and candy floss, is a spun sugar confection that will resemble like the cotton. This cotton candy has different names in different countries, and this is usually sold at fairs, carnivals, the circuses, festivals, and plastic bags mostly, and which is of course they are done on a stick and served. To make this cotton candy, you just need 3 ingredients. Especially you'll be needing 2, that is a cotton candy machine and a sugar. And of course, if you want flavoring agent like coloring agent, you can add. Now let's see what happens. The sugar and the coloring agent is mixed so that you will get a color. Let's say it is a blue color. Now this is poured into the center of the cylindrical part of that machine where it will be rotating. That will have a coil inside, and after some time you can see that there will be thread-like structures which is coming around that cylindrical part, right? But have you ever thought how this crystal of sugar, or even you can say it is powder, how that powdered or crystal sugars turns into a thread-like structure? What happens in that elements of the sugar, because sugar consists of sucrose, right? Sucrose has 3 elements in it, and what happens to it, how the structure changes? Come, let's find out. What happens? Now, as we know, sugar is of course none other than sucrose, is made up of carbon, hydrogen or oxygen. Here, what happens? The physics in here is the sugar which is poured into that cylindrical component. What happens is that when the sugar is poured, the heating element which is present in that component will heat the sugar to its melting point, that is nearly 190 degrees centigrade. Now the motor in that container will spin very quickly, even at a speed of 60 revolutions per second. Now what happens according to chemistry is that these hydrogen and oxygen will combine to form water, and water evaporates by the means of heat. Now we will only have the carbon left. Now this carbon burns and the sugar will start to caramelize. Now the sugar is caramelized, and we also had a property of melting property in the first. Now we'll be seeing about centrifugal force. Now, as we know, these containers will also have small holes on the top and the side. Due to the rotation of the coil or else the component, the centrifugal force will push the hot syrup, that is the hot liquid syrup, into these holes. Now this hot syrup will come in contact with the cold air, so that will solidify and it will become long skinny strands. These strands are just about 50 micrometer in diameter, which is very small. So here we have 2 properties in this cotton candy making, that is melting point and centrifugal force. Now let's see what is centrifugal force. What is a centrifugal force? Centrifugal force is an inertial force that will appear to act on all objects when viewed under a rotating frame. None other than that, this force, in which it is a force which acts on the outward direction, that if there is something applied to that object, when it is rotating, when it is in motion, then it will give something in the outward direction. That is called a centrifugal force. Now we can prove it by 2 laws, that is second law of motion and third law of motion, that is none other than Newton's laws. So Newton's second law of motion says that a force causes an acceleration indeed, and the third law indicates every action has an opposite and equal reaction. Now what happens is here that the melted sugar is to accelerate outward through the small holes in a response of the centripetal force which is generated because of the rotation of the pan, and this sugar will maintain circular path inside the pan because of the centripetal force towards the pan center. Now what happens is here centripetal force is created, and as we know by the third law, the motion will have the action will have an opposite reaction, and so this causes centrifugal force to come into the picture. Now this centrifugal force will act, and so that the melted sugar will ooze out of the small holes and come in contact with the air, and it will form small threads. Now we are going to see the physics in marshmallows. Yeah, what are the ingredients in marshmallows is that it is as simple as cotton candy, none other than sugar, water, air and gelatin. Yeah, now let's see changing of pressure. Now we have seen that ingredients. Let's see what happens and what role does it play. Sugar makes them sweet, sugar and water will combine and make them sticky, and gelatin will make them stretchy. So that, as we all know, marshmallow is sticky and it is so stretchy, it comes when you bite. And then now the air which is made of that, it is of course made up of air, full of air, right?
Here, the air is important for the volume of the marshmallow.
Now, for example, you are putting the marshmallow in a jar and closing it. Now, as you pump air out of the jar, so if you pump air out of the jar, what happens is that air which is present inside the marshmallow will expand, and the marshmallow will puff up. It will become more and more puffy. Yeah. Now, if you release the seal, the marshmallow will return to its normal size as before. Right? Why does it happen? And this will explain Boyle's law. Boyle's law. Boyle's law states that when the temperature doesn't change, the relationship between pressure and the volume is inversely proportional. It means that in this case, what we did was we kept the temperature constant. We didn't touch any temperature. It was in room temperature. We didn't touch it, and here the pressure and the volume was inversely proportional. How? Yes, we lowered the pressure and the volume. Now let's see the changing of temperature, our last topic. Now first we are keeping the marshmallow in a microwave, and the microwave will bake the marshmallow. The water in the marshmallow will heat up and warm the air. Now the air will become so hot and it will expand, which will of course force the marshmallow to puff up, right? Now what happens, see in the diagram, that when the temperature is hot, the balloon is expanding, and when the temperature is cool, the volume or the balloon decreases. Explain, what is this? Why it does it happen? It is none other than it is because of Charles' law. Charles' law. When the pressure on a sample of a dry grass is held constant, the Kelvin temperature and the volume will be in direct proportion. Now, what they say is here is we are keeping pressure as constant, and the temperature and the volume is directly proportional to each other. So, as absolute temperature increases, the volume of the gas also increases, right? Now, as we saw in the balloon case, when you heated, the volume increased. When you cooled it, the volume decreased, and they are proportional to each other. This states Charles' law, and thus we have explained the physics in here by two laws, that is Boyle's law and Charles' law. Thank you.